Sometimes we want to evaluate functions that are given by formulas. So let's practice that. So here we've got three different functions. And so let's break down the notation again. So here this f is our name of our function. And the x is our input variable. All right, so in this first example, f of x equals 3x minus 1. What this means is if we plug in x, whatever number x represents, to our function f, then the output will be 3 times x minus 1, 3x minus 1. And so we can do this with other formulas defining other functions. So g of x here, g of x would be another function name. But we still are using the same x as our input variable. We don't have to use x always, but it's the standard choice. And we could also have h of x as another function. G of x here is defined by 2 to the power x minus 1. So if we plug x in, we get 2 to the power x minus 1 out. H of x here, if we plug x in, 3 minus x to the power 2 comes out. Okay, so we have formulas defining these functions. They just tell us if we plug in some random number, this is how we would compute the output. So let's try that. So if we evaluate f at the input 0, what do we get? So we're looking for f of 0. Input 0, the output is f of 0. So what we do is we take our formula here, and let me actually copy and paste that so for reference. So we take our formula and we're looking, so the formula is f of x, the general setup. Now we're looking at f of 0. So we take these x's and we transform them into zeros because those are our inputs in this example. So 3x, that's going to become 3 times 0. 3 times x becomes 3 times 0, and then the minus 1 stays the same. So now f of 0 is this expression, which we can continue to simplify. 3 times 0, we multiply before we subtract by order of operation, so 3 times 0 is 0, minus 1 is negative 1. So f of 0 equals negative 1. Okay, let's try another evaluation using that same formula. So if we evaluate f at 2, f at the input 2, what do we get? So f of 2 here, we're taking the same formula, 3x minus 1. The x becomes a 2 this time, but the 3 stays the same. X becomes a 2, 3 times 2, and then the minus 1 stays the same. So this would be 6 minus 1 is 5. So f of 2 equals 5. Input 2, output 5. All right, and it works the same for these other formulas. So let's try those. So if we evaluate the function g at the input 3, what do we get? F of, g of 3. We want to find the output when we input 3. And now we're using a different formula. We're using g of x. So we got to use this new formula here. So let me, just for sake of illustration here, copy and paste that again. So the x's become 3's. Everything else stays the same. G of x, the general input is x. Now we're looking at the specific input 3. So the 2 stays the same. The x becomes a 3. The minus 1 stays the same. All right, and then we simplify. So 2 to the third power, that's 2 times 2 times 2 minus 1. 2 times 2 is 4, times 2 again is 8, minus 1, 8 minus 1 is 7. So input 3, we get 7 out. And the last example, let's evaluate h at negative 2. Okay, so again, we're going to look at this new formula for h of x. The only thing that changes is x is negative 2, because our input now is negative 2 instead of this general x. So 3 stays the same, the exponent stays the same, but now x becomes a negative 2. And I'm going to put parentheses around this negative 2 because I want to make sure that the negative 2 gets squared, not just the 2. We got to be careful with order of operations when we're making these substitutions. We're replacing x by different numbers. So then we simplify. Negative 2 squared is negative 2 times negative 2. Negative 2 times negative 2 is the same thing as positive 4. So 3 minus 4 gives us negative 1 as our output.